Hi students, so today I am going to discuss about the preparation or synthesis of one of the condensed polymer which is obtained by the condensation or step growth polymerization, that is the bakelite or phenol-formaldehyde resin. Bakelite or phenol-formaldehyde resin. So already I have explained in the previous classes that the most toughest job to write the preparation of any of the polymer is to remember the starting materials, that is to remember the monomer units. So in this particular preparation, the starting materials can be easily remembered with the help of the second name associated with the bakelite, which is phenol-formaldehyde resin. Phenol-formaldehyde resin. The name itself suggests that it is the polymer of the phenol and formaldehyde. Phenol and formaldehyde. So based upon this, it is very clear that the starting materials required for the preparation or synthesis of bakelite or phenol and formaldehyde. Now what is the phenol, students? Phenol is the benzene with hydroxyl group. Benzene with hydroxyl group is phenol. So in the step one, phenol. What is phenol, students? Benzene with hydroxy group. Benzene with hydroxy group or phenol with hydroxy group is nothing but phenyl with hydroxy group is nothing but the phenol. Another starting material required for the preparation of the bakelite or the phenol-formaldehyde resin is formaldehyde, students. So one starting material is the phenol, another starting material is the formaldehyde, which is required for the preparation of the bakelite because the second name suggests the starting materials. Phenol plus formaldehyde. So formaldehyde, I don't want to complicate its structure by writing the precise structure of that particular formaldehyde, but so in this manner you have to remember the structure of the formaldehyde, students. That is HCHO. HCHO is formaldehyde. HCHO is formaldehyde, students. HCHO is formaldehyde. Now, this reaction between the phenol and formaldehyde is facilitated by acid. Facilitated means what term? The reaction between the phenol and formaldehyde takes place in the presence of an acid. Acid is H+. That is acidity of any of the substance can be expressed in terms of H+ ions. That's the reason I'm expressing the acid in terms of H+ ions. Now dear students, in order to remember the products which are obtained by the chemical reaction between the phenol and formaldehyde in the presence of an acid, I'm going to give one tip for you. So before going to give the tip for you, in order to remember the products which are obtained by chemically reacting the phenol with formaldehyde in the presence of an acid. So see students, here phenol, here hydroxy is the substituent. Hydroxy is a substituent which is present on the benzene nucleus. Now, this is the first position with respect to the substituent. What is the substituent, students? The substituent on the benzene nucleus is hydroxyl group. The first position with respect to substituent is this one, and this is the second position with respect to the hydroxyl group, which is the substituent, and this is the third position with respect to the substituent hydroxyl group. Now students, do remember that the first position with respect to substituent on the benzene, in this case hydroxyl group is ortho, and the second position with respect to the substituent, in this case hydroxyl group, is meta, and third position with respect to the substituent, which is hydroxyl group, here is para, right? So this sort of information is required for writing the product. What is ortho, what is meta, and what is para. Now the tip is, in order to write the products which are obtained when the phenol is reacting with formaldehyde in the presence of an acid, what you need to do is write down the two phenolic moieties. Write down the two phenolic moieties, students. OH, two phenolic moieties, plus OH, phenol, same, no change, two phenolic moieties. Now see here. So now what we need to do is, what is this position, students? This is the first position with respect to the substituent, so ortho. Second position with respect to substituent, meta. Third position with respect to the substituent is para. Similarly here, first position with respect to substituent hydroxy is ortho, second position with respect to the substituent is meta, and the third position with respect to the substituent is para. Right? Now I hope you've understood what exactly is ortho, meta, and para. Ortho, meta, and para. Now, so in order to remember the structures, only I am explaining in this manner, students, but this will not exactly happen during the reaction. So in order to remember the structure, what you need to do is combine the carbon on this and two hydrogens, so CH2OH from the acid. CH2OH. Now what we need to do is, this CH2OH should be placed at the ortho position, and the same CH2OH should be placed at the para position, students. Should be placed at para position. CH2OH at the ortho position, the same CH2OH at the para position. There is no need to mug up or memorize the structures of the products which were being obtained by chemically reacting the phenol with the formaldehyde in the presence of an acid. Now, what is the name of this? So see here, students. At ortho position, hydroxyl group is there, methyl is there, and this is phenol. Right? At ortho position, hydroxyl group is there, methyl group is there, phenol group is there. So accordingly, what it will become, students? Ortho hydroxy. This is methyl. What is the moiety thus? This moiety is phenol. Ortho, as it is at the ortho position, it is ortho, and hydroxy, CH2 is methyl, and the remaining moiety is phenol. So this is ortho hydroxy methyl phenol. Now coming to the name of this, another product which is obtained is, this hydroxyl group is at the para position. So since it is at the para position, it is para. At para position, what is that, students? Hydroxy. Para hydroxy. This is methyl phenol. Para hydroxy methyl phenol. Para hydroxy methyl phenol. So this is your first step, students. That is, first steps involves the reaction between the phenol and formaldehyde. And this reaction between the phenol and the formaldehyde is facilitated by an acid. Now, what happens? The CH2OH of the reagent takes place at CH2OH. And the same CH2OH will take its place at para position also, by which orthohydroxymethylphenol and para-hydroxymethylphenol are the products being obtained, Now students, one more point I want to focus here. What is the valency of the carbon, students? The valency of the carbon is 4, right? So since childhood you have been studying the valency of the carbon. The valency of the carbon is 4. Since the valency of the carbon is 4, around the carbon we need to ensure the 4 bonds. If it is lacking the bonds, what we need to do? We have to place the hydrogens over there. Accordingly. This is the first carbon. This is the first carbon. And what does circle mean, students? Circle means the presence of alternate double bonds. Circle means the presence of alternate double bonds. So let us count the number of bonds around the first carbon. So let us label them. 1, 2, 3, 4, 5, 6. Right. So let us talk about the first carbon. Right. So at the first carbon, around the first carbon, how many bonds are there? 1, 2, 3, 4. So 4 bonds are there. So the valency of the carbon is 4, and as the valency of carbon is 4, and as the 4 bonds are there around the first carbon, we can say that the valency of the carbon has been satisfied without placing the hydrogens. So in the similar fashion here also, in the second carbon, around this second carbon, 1, 2, 3, 4. Around the second carbon, 1, 2, 3, 4. So 4 bonds are present. So in the similar fashion, there won't be any hydrogen associated with this particular second carbon. Now coming to the third carbon, students. Around third carbon, 1, 2, 3. So now it is lacking 1 bond. It is lacking 1 bond means there will be 1 hydrogen. So around this carbon, around this fourth carbon, 1, 2, 3, it is lacking 1 bond. So we have to place 1 hydrogen over there. So around this same 1 hydrogen, around this same. Now what my intention is, if on the benzene nucleus there is any substituent, then the hydrogen won't be a part of that carbon. And if there is no substituent on that particular carbon, there will be a hydrogen attached to the carbon. That is my intention. If there is a substituent on the benzene nucleus, or if there is a substituent on the carbon atom, then there won't be the hydrogen. If there is no substituent on one of the carbon of the benzene nucleus, then hydrogen will be part of it in order to satisfy the valency. So without substituent, this 1 hydrogen will be attached to the carbon which is a part of the benzene nucleus. With the substituent, there won't be the hydrogen. Keep that in the mind. With the substituent, there will be the hydrogen. Right. I hope you understood this. Now coming to the step 2. This step 2 involves the reaction between the major product which is so obtained in the first step with the phenol. Now the question is, among the orthohydroxymethyl phenol and para-hydroxymethyl phenol, which is the major product? Which is the major? Now among these two, orthohydroxymethyl phenol and para-hydroxymethyl phenol, which are being obtained by the chemical reaction between the phenol and formaldehyde in the presence of an acid, orthohydroxymethyl phenol is the major product. Why? Due to the presence of chelation. Chelation means hydrogen bonding. And what is hydrogen bonding, and where the hydrogen bonding takes place? The hydrogen bonding takes place between the most electronegative atom and the least electronegative atom. So see here, students, there is the most electronegative atom, oxygen, which is directly attached to the benzene nucleus, and there is a least electronegative atom which is directly attached to the oxygen. Now here there will be the hydrogen bonding. So due to this hydrogen bonding, what happens? It will become the major product. And whatever the major product which is being formed in the one step, that will carry forward the reaction further. Now among the orthohydroxymethyl phenol and para-hydroxymethyl phenol, orthohydroxymethyl phenol is the major product due to the presence of chelation, that is the hydrogen bonding between the oxygen of this and the hydrogen of this, and oxygen of this and the hydrogen of this. So this is intramolecular hydrogen. I don't want to emphasize on the intramolecular hydrogen bonding, but do remember that among the orthohydroxymethyl phenol and para-hydroxymethyl phenol, orthohydroxymethyl phenol is the stable or the major product because of the chelation or hydrogen bond. Now as it is the major product, it will carry forward the further reaction. Now in the second step, what we need to do is we have to arrange the orthohydroxymethyl phenol molecules and phenol molecules in such a manner that hydroxyl groups and hydrogen groups are visualized. This can be visualized. In the second step, arrange the major product which is so obtained in the first step, that is orthohydroxymethyl phenol and the phenol in such a manner that hydroxyl group and hydrogen group is visualized, that is can be visualized. So to arrange in that fashion. So coming to the step 2, students. Step 2. So phenol, this orthohydroxymethyl phenol, which reacts with phenol, and already have clearly explained, students, that if there is any substituent on the carbon of the benzene nucleus, then there won't be any hydrogen on that particular carbon. But if there is no substituent on the carbon atom of the benzene nucleus, there will be the hydrogens. So there is no substituent here, so the hydrogens will be attached. Right. So along with this, now it will react with another molecule of orthohydroxymethyl phenol. Now the question is whether CH2OH should be placed on the left side or right side. Whether the CH2OH should be placed on left side or the right side with respect to hydroxyl group. What I said, students, We have to arrange the phenolic moieties and orthohydroxymethylphenol in such a manner that hydroxyl and hydrogen can be visualized. So hydrogen is there on the right side, means hydroxy group should be there on left side. Hydroxy group should be there on left side. Hydroxy group should be there on left side. So again, hydrogen, students, plus orthohydroxymethylphenol So again, hydrogen is there on right side. So in order to visualize the hydroxyl, it should be there on left side. It should be there on left side. So n numbers. Right. So they undergo the polymerization. N number of this orthohydroxymethylphenol and phenol undergo the polymerization, resulting in the formation of linear polymer. Now, by seeing the structure, just guess what are the molecules which are going to be eliminated. Hydroxy of this, hydrogen of this. Hydrogen of this, hydroxy of this. Hydrogen of this, hydroxy of this. That is, H will combine with the OH. That is, water molecule is going to be lost. Water molecule is going to be lost. How, students? OH, H, H, OH, H, OH. Again, it will be H, OH, and so on, because the polymerization. It is the polymerization. So, n number of water molecules, as it is the polymerization, and as the water molecules are being lost, n number of water molecules will be lost. Now, what is the resulting structure? What is the resulting structure? And don't become panic after seeing the resulting structure, students, because the resulting structure is very simple to remember. It is phenol, followed by, what is that? CH2. OH has been lost. Now, what is that, students? Phenol, followed by HOH has been lost, CH2, followed by, what is that, students? Phenol, HOH has been lost, CH2. So next it will be phenol, next CH2. So phenol, CH2, phenol, CH2, phenol, CH2, phenol, CH2. So the structure looks complicated, but it is very simple. What you need to do? Phenolic moiety followed by CH2. Phenol followed by CH2. Phenol followed by CH2. Phenol followed by CH2. Phenol followed by CH2. That's it. Okay, and this is the linear polymer, students. This is the linear polymer. This is the linear polymer, and the name of this linear polymer is Novolac. And I've clearly explained to you while explaining the classification of the polymers based upon the structure that among the linear, branched and cross-linked polymer is the stable and the rigid polymer and strong polymer. So as the linear polymer is obtained, it is not strong, it is not stable. So since it is not stable, since it is not strong or rigid, we need to convert this linear polymer into cross-linked polymer. Right. We have to convert this linear polymer Novolac into cross-linked polymer in order to enhance the strength of the linear polymer Novolac. Now, for getting the structure of the Bakelite, what you need to do is simple, students. Write down the linear polymer Novolac. So what is present, students? Phenol. There should not be any ambiguity. only phenol followed by CH2. Phenol followed by CH2. Phenol followed by CH2. Phenol followed by CH2, and so on. So whenever this linear polymer novolac is treated with the hexamethylene tetraamine, CH2 taken 6N4, hexamethylene tetraamine, then the following structure is being resulted. That is, the linear polymer novolac will be converted into the cross-linked polymer bakelite. Now, one of the linear polymer has been formed. Linear polymer has been formed whenever hexamethylene tetraamine is added to the novolac. Now, in the similar fashion, so many linear polymers are going to be formed in the similar fashion. Now, in order to remember the structure of the bakelite, what you need to do is just write down the mirror image of this by placing the mirror here. Not a side. Okay, you're not placing the mirror the sideways. You are placing the mirror below this molecule. When you place the mirror below this molecule, what happens, students? Whatever the group which is oriented at the top, now it will orient at the bottom. Now, what is the moiety? What is the group which is oriented at the top? Hydroxyl group, hydroxyl group, hydroxyl group, hydroxyl group, hydroxyl group. Hydroxyl group is oriented at the top. Now, since it is oriented at the top, whenever the mirror is placed here, now it will orient at the bottom. Now, do remember, students, this CH2 will be always at ortho position only. Why the CH2 will be at ortho position, students? Because ortho-hydroxy methyl phenol is the major product which is formed in the first step by the chemical reaction between the phenol and the formaldehyde in the presence of an acid. That is the reason the CH2 groups will link at the ortho position only. Ortho position with respect to substituent. What is the substituent? Hydroxyl group. Hydroxyl group. So there should not be any ambiguity. Ortho, hydroxy. What is ortho, students? Ortho is the first position with respect to substituent. Hydroxy is there, means ortho means first position with respect to hydroxy. This is CH2. CH2 followed by again, right, hydroxy, first position with respect to substituent, ortho. At ortho you have to place CH2. Next, another molecule, hydroxy, right. Next, at first position with respect to hydroxy, that is ortho position. Next, hydroxy followed by now this is one of the linear polymer, and this is another linear polymer. When this linear polymer novolac is treated with hexamethylene tetraamine, what happens is cross linkages are developed in between the adjacent linear novolac molecules, resulting in the formation of cross-linked polymer, the bakelite. Now, this hexamethylene tetraamine is enriched with methylene. CH2 means methylene. As it is enriched with methylene molecules, now the cross linkages between the two adjacent linear novolac molecules are generated by methylene groups. So what you need to do? just link this benzene nucleus with this benzene nucleus with CH2. Link this benzene nucleus with CH2 with this. Link this benzene nucleus with this with CH2. Now link this benzene nucleus with this benzene nucleus with CH2. With CH2. With CH2. So as it is a polymer, n number of methylene groups, n number of cross linkages are going to be generated in the presence of hexamethylene tetraamine. And this methylene groups which are being generated between the two adjacent monomeric chains are the cross linkages. Now since these are the cross linkages, we can say that this particular molecule, this particular compound which has been obtained by the chemical reaction of the linear polymer Novolac in the presence of hexamethylene tetraamine is cross-linked polymer. Is cross-linked polymer, and this cross-linked polymer is Bakelite. This cross-linked polymer is Bakelite. And this Bakelite, as it is a cross-linked polymer, it is very strong, stiff and rigid in nature, and that is the reason the Bakelite possesses excellent insulating property because of its greater strength, higher stiffness and rigidity. It possesses excellent insulating property. That is the reason the Bakelite is most widely used for making the switchboards, switches, plugs. Everything is made up of the Bakelite because it is the cross-linked polymer. It is a cross-linked. So now these are the three steps involved for the preparation or synthesis of the Bakelite, which is also called as Phenol-formaldehyde resin, students. So I want to emphasize only one point here, that is definitely in order to remember the starting material required for the preparation or synthesis of the Bakelite, you need to remember the second name of the Bakelite. The second name of the Bakelite is Phenol-formaldehyde resin. As it is Phenol-formaldehyde resin, one of the starting material required for the preparation or synthesis of the Bakelite is phenol. Another starting material which is required for the preparation of Bakelite or Phenol-formaldehyde resin is formaldehyde. I hope you understood this video. I hope you understood this particular preparation or synthesis of the Bakelite or Phenol-formaldehyde resin. And do remember, student, this particular preparation of Bakelite or Phenol-formaldehyde resin is very, very important from the examination point of view. So thanks for watching, student.